everyone. So this is the question asked in the GATE 2011. So the question is, so there are the three processes are there, P1, P2 and P3, and each process has an arrival time 0, 2 and 3, and there is a priority for each process equal to P1 process has a priority 2 and P2 process has a priority 3 and the P3 process the 1 is a priority. According to that, the 1 is the highest priority and then P2 has the 3, that is the lowest priority, and then each process is given as the CPU time, input output time and then again CPU time, right. So by using the multi-programming operating system, and we need to use the preemptive priority scheduling. So what is the completion time of each processes? So we need to find out, right. So in order to solve this question, so first of all we need to know what is the CPU time and input output time and again CPU time, right. So in multi-programming operating system, so in order to solve any process, right, the process may requires two types of time. So one is the CPU time, another one is input and output time, right. So whenever the process P1 and P2 and the P3 are ready to execute, right. So while executing the process, each process will be varies by the 5 stages, right. So according to the 5 stages, whenever the P1 process ready to execute, then the P1 process first will come to the ready state at the different various time. Then we have the P1, let us take the 0 at the time it will come to the ready state, and whenever the P1 is come to the ready state and it is ready to execute, then it will we are moving this P1 process to the running state, right. So while the P1 process will be moved to the running state, right, how much time the P1 process will execute it in the running state, then we call it as the CPU time, right. So once it is completed the CPU time, and in order to complete this one, so it may requires some input and output device time, then we need to be send this, if it is the P1 process require the input and output time, then we need to send this P1 process to the waiting state, right. So how much time the process will be spending the time in the waiting state, we call it as the input and output time, right. So after completion of this input output time, again it will go to the ready and then be given to the running state, and this is the time we are going to be complete this. So right, so in order to solve the multi-programming and this problem, then each process may require the two times, one is the CPU, another one is input and output time, right. The CPU time is nothing but how much time the P1 process will be there in the process to complete, and the input output time is nothing but how much time each process spending in the waiting state, right. So coming to this problem, right, so how many processes we have? The three processes are there, P1, P2 and P3, and the arrival, the P1 is arrival at the 0 unit of time, and the P2 arrival at the second unit of time, and P3 is arrival at the third unit of time, right. So from this given priority, so which has the highest priority means the P3 is the highest priority, means the lowest number will indicate the highest priority. After then the P2 is the lowest priority, of the P1 is the second, and the P1 is the next highest priority, and the P2 is the lowest priority, right. So this is the priority order. The priority of the P3 is the highest, and the lowest value will indicate the highest priority, and the highest value will be indicated to the lowest priority, right. So by using the preemptive priority scheduling, so what is the completion time or the finisher time of each process, right. So what is meant by preemptive priority scheduling, right. So I am going to start with the Gantt chart, right, and I am required one ready queue. So in order to find out at what time each process is coming to the ready queue, right. Right. So at the 0th time, how many processes are available means only that the 0 time according to the question the P1 process only arrival. Then so in the ready queue at the 0 time P1 process only available, right. So now there is no option to us, then obviously we need to allocate the P1 process to the CPU, right. How many units it will be run means the CPU the first time it will go to the 1 unit of time. So I am running for the CPU for 1 unit of time, right. After 1 unit of time P1, so what the CPU will be, VP will go to the input output time for the 5 units of time, right. So what is the 5 minutes means 1, 2, 3, 4, 5, 6, right. So 1, 2, 3, 4, 5, and this time the process P1 will enters into the input output state, means waiting state. So we are not going to be allocated this P1 process to the CPU time at this interval of time, right. So now at this P1 is completed, now we are at the 1 unit of time, At the 1 unit of time, is there any process will came to the ready queue or not, right? So at the 1 unit of time, no process will came. At the second unit of time, P2 process came to the ready queue, and the third unit of time, P3 process came to the ready queue. So what it means, at the 1 and 2, this slot is an empty slot, right? So there is no work in progress. Now at the second unit of time, the P2 process came to the ready queue, right? So now I am going to be, there is no option to us, then obviously I will allocate the P2 process to the CPU, right? How many units it will be run means the P2 process run for the next process will come to the ready queue, right? So whenever the next process coming at the third unit of time, the P3 process came to the ready queue, right? I will run for the third unit. At the third unit of time, the P3 process there in the ready queue, right? So in order to find out which process I need to be select next to give to the CPU means I need to check for the priority of each process, right? So what is the priority of the P2 and P3 means the relationship between the priority is the P2 is very less priority than the P3 process. So I am allocating the P3 process to the CPU, and there are only two processes are available, P2 and P3, and P3 is the highest priority, right? So we are not going to be stop the P3 process because the P3 is the highest priority than P2, then I will complete the P3 process until the completion. So how many units the P3 process required? The 2 units of time required by the P3 to complete, then I am allocating the 2 units of time. Now the P3 process is completed. After completion of the P3 process, the P3 process will go to the input output time, the 3 units, right? 1, 2 and 3. At this time, the P3 process will go to the input output time, means at this time we are not allocating this P3 process to the CPU, right? Now the P3 completed, then only the option is the P2 process available in the ready queue, then I will run the given the CPU to the P2 process. I will run for only 1 unit of time. Why? Because the P1 process at the 6th unit time it completed the input output time and it came to the ready queue, right? At the 6th unit of time we have the P1 and P2, and in order to give the which process I need to give the CPU means first I need to check for the priority of each process. So what is the priority relation between this one means the P1 has the highest priority than the P2, then I am going to be allocating this process CPU time to the P1 process, and the P1 process will run for how many unit of time P1 process will run means there is a 3 units of time required by the P1 process, when I am running for only 2 units of time, right? So let us say 7 and 8. At this time the P3 process complete the input output time and came to the ready queue. Now the ready queue will contain by the 3 process P1, P3 and P2, right? So now I need to be, in order to give to the CPU and which process I need to be selected means out of the 3 process which process has the highest priority, right? So the P3, the relation is the P3 is the highest priority. Now I am going to be allocated the P3, then how much time it will taken by the P3 means after completion of waiting time the process will be require only the 1 unit of CPU time, then I given this 1 unit of time. At the 9 the P3 is completed. At the 9 P3 is completed. Now there are only the 2 process P1 and P2, and the P1 has the highest priority. Now I am going to be allocating this P1 to the CPU, right? How many units already completed? There are 2 units are already completed, but P1 is required the 3 units of time means out of the 2 already completed, remaining is only 1. Now the P1 process I given, and then completion equal to P10. Now the P1 process also completed. Clear? Now the only one process is available in the ready queue, and this is the P2, right? How many slots are already completed means this is the 1 and 2, and how much time it will take means 3 units of time it will take. Then I am going to be allocated the P2 to the 1 more time, then it is the 11. After completion of the 3 units of time, the P2 process will go to the ready input output state, and means 3 units of time 12, 13, 14. At this time the P2 process will go to the input and output time. So we are not allocating this time to the P2 CPU to the P2 process. After completion of the P2 process, only the one process only available. Now I am going to allocate a remaining time equal how much time it will take? Only 1 unit of time. At this 1 unit of time the P2 process completed, right? So now what is the completion time for all the process means it is the preemptive. So preemptive scheduling algorithm, the completion time will be taken from right to left, right? So now find out the what is the completion time of the P1 means the completion time of P2 is equal to 15, and the completion time of P1, the completion time of P1 equal to 10, and the completion time of P3, now completion time of P3 equal to 9, right? So what is the order? The P1 completes at the 10 units of time, and P2 completes at the 15 units of time, and P3 completes the 9 units of time. Then what is the output? Then answer is B, 10, 15 and 9, right? So this is the answer.